Welcome to today's webinar, announcing AWS OpsWorks for Chef Automate. Our presenter today is Amir Golan. Amir is a Senior Product Manager for AWS OpsWorks. Today with us, we also have Praveen, Mark, and Jens. They are our webinar moderators who will be engaging with you and answering your questions throughout the presentation. Amir, welcome. The floor is now yours.
Thank you very much. Welcome, everyone. We're very excited today here with the team announcing OpsWorks for Chef Automate. For those of you who have been following reInvent announcements, this is where we launched, and the service is now live, so we all welcome you to go and check it out. So let's get started. So in today's session, we're going to talk about configuration management and help you understand how you can use configuration management to refer to your infrastructure as code. And what exactly does that mean? Right? Version controlling your code, version controlling your infrastructure, and what are the benefits of doing just that? We're also going to help you understand how configuration management can help you save time, where you can actually go from 0 to 100, spinning up new instances and have them fully configured in just minutes. We're also going to talk about and show you some of the best practices of setting up your infrastructure, host configuration, and application configuration. So let's start with a little bit of background of how we got to where we are today. So the background starts like this, where back in the pre-cloud days, infrastructure was mostly static. That means I would have had to anticipate in advance how my infrastructure would look like. That means I wasn't supposed to be very fast. In today's world, it's a little different, right? We can get new infrastructure in just minutes. And when we get new infrastructure, that means we also have to have that infrastructure configured properly, right? So we need to achieve more speed, right? So as time progresses, our job actually becomes a little bit more harder each and every day because we need to keep up with that speed and we need to keep up with our infrastructure. And we all are now a part of a fast-moving environment that is constantly requiring more and more attention. Attention that brings by configuration management as one of the solutions. So to talk about how most of our customers see configuration management, we have this definition right here. Configuration management is a practice in which code is used to define and maintain the state of both new and existing resources throughout their entire life cycle. I'd like to focus on that last bit, throughout their entire life cycle. That means from the time the instance is created until it is terminated and everything in between. So that means like the time you had to clear out some locks or clear out some space, or remove several SSH keys because some users left the company. That means all of it. So, to bring up some more specific use cases of how you could use configuration management to your benefit, the first thing it lets you do is let you store your entire host configuration in a single place. And just like having source control for your code, the same thing applies for your infrastructure. Also, I mentioned something I already mentioned before. You can go to 0 to 100. That means you can spin up blank resources, blank instances, servers that work perfectly every time and will boot with a proper configuration by using configuration management and the configuration files within them to bootstrap the instances properly every single time they come up. Configuration management also lets me do changes in a single place and propagate those changes throughout my entire environment, or in the rest of my environments. That means development, test, and production. All of my environments could be properly configured repeatedly every single time. So to give you an example of where configuration management would exactly come into play, I'm going to go through this simple illustration. So on the left, we have our compute resources. Now, those could be Amazon EC2 instances. They could be your on-prem servers. It could even be your developer desktop, right? All these will be your compute resources. When it comes to configurations or types of configuration that you can do on those compute resources, you have setting up files, setting up directories, defining networking settings, creating symlinks, mount points, registry keys, and many, many more. Also that you can support your applications, which also have their own dependencies, right? And the application configuration itself, service registration, credentials, and a lot more things which relate to your application. And even after you do that, and you use configuration management to do all of this, you'll still have some more work to do, because even after you have your application running, you're not really done. You still have to deal with package updates, deploying and shipping new software, changing the configuration, right? Or even setting up environment-specific changes. That means changes that only apply to my dev environment, but not to my production, or vice versa. Of course, you also need to run commands on your fleets of instances. And of course, the last and most important piece, you need to be on top of every single resources and know exactly what is going on at every minute. So how can you get on top of these, on top of all of your resources, and what sort of things you can do? You need tools. Tools to help you tackle some of the common challenges that we know today, like changing the vhost configuration of every web server across multiple environments, or installing a package on a certain host to test out a new version, or changing the LDAP settings on a specific Amazon Linux instance, but not under my Ubuntu fleet. So what sort of tools can I use to tackle some of these common challenges? Well, you probably guessed it by now, but we just launched OpsWorks for Chef Automate. So let's talk a little bit about what Chef Automate is. Chef Automate is an automation suite, a host or suite of tools to help you tackle some of these common challenges, and how to drive automation and how to drive operational excellence in your environments, which is what we're going to be talking about today. So let's start by describing a little bit what Chef Automate does. So at its core, we're talking about a way to refer to your infrastructure as code. And this is done in Chef using cookbooks and recipes. Now, cookbooks, and you'll notice a reappearing cooking narrative in Chef products. Cookbooks and recipes are used to define the state that which your instances will eventually be configured in. It uses Ruby DSL to define that state and configure that state later on. Those cookbooks and recipes is what you'll use to install and configure the software components, manage files, deploy and scale your application, and even you'll use them to execute other cookbooks and recipes, right? So basically, a chef recipe can also execute other chef recipes, as you'll see in the demonstration that we'll show in the end of the session. What it also helps you do is align resources with a specific policy. So if I want to define how every database server looks in my org, I will use Chef to do it, and I will codify that in Chef cookbooks and recipes. And I'll use those cookbooks and recipes to spin up database servers the same way every single time in my dev, my test, and my production environments. Exactly the same. And of course, when I automate everything and when I have the configuration of every single server in code, which can be executed at moment's time, I save a lot of time because it helps me automate this process, and not only the bootstrapping process, but the entire life cycle of maintaining those resources. I can also do patch management, right? I can also do auditing and everything that I need to do to maintain and keep control over my fleets of instances. So how does Chef really work? Well, it uses a simple client-server architecture where you got your resources or instances connecting to something that's called a Chef server. And those resources pull for configuration updates directly from that Chef server. In this illustration, we have two sets of configuration, config A and config B, where each of those can describe a different tier of my application. So config A could be a set of cookbooks and recipes that will eventually define a web server. Well, config B could be a database server, right? The cookbooks and recipes that make up database servers. And of course, they can also be, aside from different tiers, they can also be different types of web applications, or I define what these are. And I do this again using those cookbooks and recipes written in Ruby. Okay, so how can I set this up? The first step would be to set up your own Chef server, and we'll talk about how to do that in the rest of the session. The next thing I'm going to do with it is I'm going to upload some cookbooks and recipes on top to that Chef server, and I'm going to define some roles, Chef roles. Now, roles are very unique, and they define what a specific purpose a certain server is meant to serve. So if I define a web server role, every single resource that will identify itself as a Chef, as a web server, will actually run a set of recipes that make up of a web server. So imagine we have 3 different cookbooks that, if installed on a certain instance, will eventually make up of a web server. So I'll define a web server role and will assign, inside something called a run list, 3 unique cookbooks that will eventually be executed on every single instance that will identify himself as a web server. So after I set up my Chef server, which we'll show how to do very shortly, I put some cookbooks and recipes on it, and I define some roles. I go ahead and install the Chef client on my instance or server. Of course, those instances could be Amazon EC2 instances. It could be on-prem physical server, or of course, it could also be your developer desktop. You decide, as long as it's a compute resources. So after I do that, I register that instance, assuming that's an instance, with the Chef server as a Chef node. And I assign that node with a specific role, right? So when the node is going to talk to the Chef server, it will identify itself as a web server, as an app server, a database server, right? So the Chef client that is installed on my instance pulls the recipes from the Chef server based on its role. And the Chef server determines the applicable recipes based on that role. After based on the role, the Chef client pulls those recipes and will then apply them using something called a Chef run, where it will execute those recipes on a certain instance. As I mentioned before, it can go from a blank instance to a fully configured instance in mere minutes. And the Chef client will continue to pull for configuration updates from the Chef server every 30 minutes, or the interval that you define as a part of the configuration of the Chef client. So as I mentioned before, the Chef client will pull configuration updates every 30 minutes, but it will only do something or make changes if actual changes are required. So if the node is not in its current state, or it is out of spec or out of sync, only in that case, the Chef client will actually do the Chef run. And the node can get out of sync by someone logging into the instance, for example, and changing the configuration, right? Removing a package that was installed in the last Chef run, or making some change in the directory structure. So the Chef client will use the recipes and see if there are any changes that were made to any host, and will rerun the recipes to bring it back into spec. And of course, it will do so only if those changes actually happen and it needs to make the changes, right? Another thing that Chef has, which is one of its great capabilities, is using something called Chef Search, which lets my system react to changes that happen in my environment. We'll talk about that later. Some of the other things that are great about the service that we just launched, which we'll talk about in a little bit, is of course the fact that it supports all the native Chef tooling. Chef Decay, Knife, CLI tool that is used to manage the server and the nodes. It supports Chef Client, which means it also supports all the variety of operating system that the Chef Client supports. It supports all the community cookbooks and recipes out of the box. Just download them and start using them. And of course, it also supports Test Kitchen. For those of you who have been wondering how Chef recipes look like, well, it looks something like this. The best thing about Chef recipes, by the way, is that you don't have to reinvent the wheel. Chef has something called the Chef Supermarket, where you can get a host of community cookbooks and recipes to run virtually anything. We're talking about MySQL, Nginx, Postgres, PHP, and a lot more. And the nice thing about recipes, as I mentioned before, recipes can contain other recipes. So let's say you want to set up your very own web server. You would probably go ahead and install an Apache package and start and enable the service. You can probably go and want to create and configure a custom site that will later be replaced by your actual site. So Chef recipes are structured in such a way that lets you do these things faster, and of course leverage or even fork some of the community knowledge that already is out there. So when you use, in this example right here, we have this first section to install Apache and start the service. As you can see, we're calling a different recipe to do just that, and we are providing him with some sensible defaults of how we'd like this to be configured. Another interesting thing I'd like everyone to take note of is the action part, where we have the create action and the start action. Now, the create action will actually install the relevant packages, and the start one will start and enable the service. But the nice thing about Chef is it provides me with abstraction. When I do a create call, I don't need to be specific about the underlying operating system, because if it was a RHEL or a CentOS system, I would probably use a certain command, a specific command, where if it was a different operating system, I would use another command. Let's say yum install versus apt-get install. I don't need to know this. Chef does this for me. Chef provides me with this abstraction. I just do a create call, and Chef does it on my behalf. I don't need to care about what underlying operating system I will run this recipe on, which is one of the great benefits of using Chef, because this abstraction saves me a whole lot of time. In the other section, you see that I can add some site configuration by calling a different recipe, the HTTPD config recipe, and it goes on and on. I can, of course, do some other things like create a directory. I can even place a placeholder file in the second bottom part of this explanation and even define an owner and a group. I can even choose to install other packages. And as I mentioned before, if you notice the bottom second half of the page, when I try to install the PHP MySQL package, again, just like before, I do action install, and Chef takes care of the rest, regardless of the underlying operating system. Me as a user don't have to care about what operating system this is going to run on, which gives me a lot of flexibility when I use out-of-the-box Chef recipes. Chef is not only about configuration management, but it's an automation suite. And we're going to talk about some of the things that you can get by using Chef Automate. The first thing we'll talk about is Chef Visibility, which is the Chef console you use to get a view into your cookbooks, your recipes, your roles, and most importantly, your notes. And what is defined in a specific recipe, cookbook, which reflects the state of the node, is the actual case. And what Chef calls a conversion status, right? Which tells me if a node is actually in spec or is in line with what I defined in a specific recipe. But this is not only a place where I can look and verify that actually what I ran on the box is actually been applied and keep track of my nodes. It's also a data warehouse platform because I can use the very same UI to query each and every node based on its role, based on its state, or based on a specific package that is installed on the node. And I can query this all directly from this console. Chef also has something called Chef Workflow, which we'll demonstrate in just a little bit. It's a continuous delivery pipeline of your infrastructure and applications, and it lets you do very, very interesting things. It lets you do a change using cookbooks and recipes and move it all the way from a developer workstation all the way up to production, while introducing built-in tests inside and guiding you through some of the best practices on how you should do your continuous delivery. It has all sorts of stages like verify, approve, build, acceptance, and deliver that you can walk through, which all have approval stages where you can share some insights with your other developers to understand whether a change is ready to be shipped. And you can track all the status of a specific change throughout this pipeline using this console. As I mentioned before, we'll demonstrate this towards the end of the session. Chef also has something called Chef Compliance. Chef Compliance helps you generate customizable reports so you can notice compliance issues, security risks, and even track outdated software. And of course, as you can see, it's also a part of the visibility console. So you can both see if your nodes are converging on a certain state, or the state that you defined in your cookbooks and recipes, or if they meet or they adhere to the state that you define, to their compliance state, in something we call inspec rules. So you define those rules. Let's say if you want to verify if the SSL-v3 package is installed on every single node that you manage, and you can use Chef to check the compliance is it really enforced. And if it's not, you can use those cookbooks and recipes to bring it into the spec that you'd like it to be in. Chef also provides with a preset of rules that adhere to security standards and frameworks like CIS benchmarks that you can use right out of the box without writing anything. So let's get back to OpsWorks for Chef Automate, which is what we just launched at reInvent. So if you've been listening to Werner's keynote, you've heard about this, and you probably heard about OpsWorks before if you've used configuration management in the past. We consider OpsWorks to be the place where you go to when you want to do configuration management on AWS. which now also offers a fully managed Chef Automate server. You can create your own Chef server in about 10 minutes, as we'll show towards the end of the session, by just giving it a name, selecting a region, and the EC2 instance type that's going to be powering your Chef server. We offer 3 different server types, a T2 medium, an M4 large, and an M4 2X large, each one designated to support a certain amount of nodes under management. Again, those nodes that will eventually run the recipes that will configure them to be in the state that you're looking to be in, to converge on a certain state. So you might ask yourself, how is this different than setting up your own Chef Automate server? Well, that's just it. There's no setting up. You just go through very simple steps, 4 steps, and you got your very own single tenant Chef Automate server running on AWS, with all the management part taking off your hands. What else can you set up in the Chef server when you create through us? You can set up a weekly maintenance window. Well, during that maintenance window, you will run security updates, Chef version upgrades, all automatically. You don't have to take care of anything. You just select the maintenance window, the time that fits you, and we take care of the rest. And we will upgrade and make sure your Chef server is fully maintained all the time. What else can you set up? You can also set up a daily or weekly backup schedule, which is a very nice thing that we offer here, because you don't even have to take care of your backups. Those backups will maintain the persistent state of everything that is Chef on your Chef server. That means all your cookbooks, your recipes, your roles, your analytics data that has been gathered about your nodes, all of that information will be kept for you. You can even define a retention period of how many of those backups you'd like to keep. Those backups are also incremental, which means they are very light on space. So just like before, you don't have to take care of your backups and your persistent data as well. We will maintain the persistent state of your Chef server for you. So you might be asking, what else is left for you to do? Well, nothing really. This is a fully managed configuration management service where we do automatic backups, security updates, Chef software updates, all for you. You can just focus on writing the best possible cookbooks and recipes that meet your specific needs, or better yet, leverage the existing community ones out of the box. Some of the other benefits you get from using our service. We also offer automatic instance of Chef server registration. We have registration and deregistration APIs that let you spin up instances even faster than you could have done by yourself. Most of our customers that use most of our customers or existing Chef customers that use it today on Amazon have to build their own tooling around how to register nodes with a certain Chef server. Now, the reason you need to build tooling is what you would normally do is you would use Knife as the mediator between a Chef node and a Chef server, where you would use Knife to help authenticate the Chef node with the Chef server and help with the registration process. Now, this works very well with static infrastructure, but doesn't work as well when you're talking about using something like auto-scaling groups, right? Which is why we have this registration and deregistration APIs, which you can use with code snippets that we'll show towards the end of the session to register your Chef nodes or instances which are soon to be Chef nodes with a Chef server, where we help you handle the authentication and registration process on your behalf, which means that you will be able to securely and easily scale using auto-scaling groups. Another interesting thing about this service is we offer Chef's commercial software, but there are no separate license fees. This is a pay-as-you-use service. That means there is an hourly charge for every node hour that is run on our service. There are no separate license fees or prepays. You pay only for what you use. We also support Amazon EC2 and on-prem resources, just like if you would do it yourself, in exactly the same way. And of course, we also provide you with the best practices, AWS support, and guidance. We are working closely with Chef on this to bring you the best possible Chef experience you could possibly have on Amazon Web Services. So you might be asking yourself now, if you haven't used Chef before, or if you're interested in configuration management, where is this supposed to come in my toolchain? When would I use this and what for? Well, some of our customers use it to bootstrap instances with the right configuration. Some of our other customers use it to update the configuration of running instances. So let's say I have instances already running, but I want to run a specific patch, right? I want to verify the specific policy is enforced. So this is exactly what I would do with Chef. I would update the configuration in a centralized place on the Chef server, and the Chef nodes will eventually pick this change up in the intervals that I predefine. By default, 30 minutes. I use Chef to assure instances compliant to a predefined policy. Right? We talked about Chef compliance, which can use inspect rules to verify a specific node is adhering to a specific set of rules or a compliance policy. And in case that's not the case, you can enforce or reinforce that policy using Chef cookbooks and recipes. And make sure those nodes converge on the right state or the right policy that you define. A lot of our other customers already use Chef as a part of your continuous integration and continuous delivery pipeline, which got a whole lot easier now with Chef Workflow. We will now pass to a live demo that will demonstrate how to use Chef on AWS.
I would like to demo some of the nice things that Amir explained so far using the slides. And I think the first thing to get started is we just head over to the AWS OpsWorks console. And as you see, you can, there's now basically the classic or the Stacks, AWS OpsWorks Stacks offering, which existed before, and there's now the new OpsWorks for Chef Automate, which we're going to head over. And on its landing page, it will basically show you the state of your Chef service. It will show you the name, whether they're in a healthy state or maybe just backing up. You can also see the version of the Chef server that's installed, and one thing to note is you can also see the region that your Chef server is in. So this is one of the things that may be worth noting, that this is actually a global console, so it will show you information about your Chef service in all regions. So you have a good overview and see how they are doing. So let's create a Chef server. So we see how easy it is and what are the 4 easy steps to create one. So first let's pick a name. We say hello webinar or hello audience. We select the region. Currently we support like 3 regions, and select the instance type. As the instance of the Chef Automate server is going to be created in your account, so it's an EC2 instance running in your account, you are optionally also able to select the SSH key, so you can SSH into the instance and customize it to your needs. But in general, we think this is not needed. Like, you will be able to do all the stuff that you need or that you would want to do with your Chef server through AWS OpsWorks. So I'm just going to skip this step. You can configure the network and security settings. In general, this is probably like the defaults. If you're just getting started, are just fine. It will default to use a default VPC, create a new security group. Everything's been taken care of. In the second half, you have these 2 settings that Amir already talked about. You can choose the maintenance window, and you can also choose the automated backups, whether they're enabled or disabled on a daily or a weekly schedule, and how many backup generations to keep. So we have a final review page, which is, as we just went over all the settings, is not that interesting. So we're just going to launch this Chef server, which is going to take a couple of minutes. What is interesting on this page is basically these 2 parts which are like in the middle. The first one is your sign-in credentials for the Chef Automate dashboard. So this is a separate web UI that will run on your EC2 instance or on your Chef Automate server, and we're going to save the credentials so we can use them later and don't lose them. And we are also going to save the starter kit, which is a zip file that contains configuration, pre-filled configuration, a certificate, and credentials, so we can interact with the Chef server on an API level. So let's also save the start kit. As I already said, the Automate server takes a couple of minutes to boot up. So what we just do is we will use this prepared server here over to in the following steps, so we don't have to wait. If we look at this prepared server, we also see how we can basically see a couple of events. So I created this about an hour ago, and you can see basically how it's, you can see it until now it does not have a couple of backups. These would show up here otherwise. So let's head over to the starter kit and see what we can actually do there. So in this case, I saved the starter kit, and we unzip it using the known commands, and you can already see that it has a couple of configuration files in it. So and these make it very easy to interact with your Chef server using the standard tools like Knife or Burks, for instance. So for those who are not familiar with these tools yet, they work in a similar fashion like Git. So they work depending on the directory that you are in. So if I switch into this directory, they will now pick up the configuration from this .chef directory, so they will automatically know which Chef server to talk to. So let's look how our Chef server looks like. So we could say Knife cookbooks list to see which cookbooks are currently installed on the Chef server, and as we just booted it up, it's completely blank. But we already got something prepared for you. So we generated a Burks file which declares dependency, and the main thing that we want you to, or that is recommended to use, is you can use the Chef client cookbook to bootstrap your nodes. So let's pre-fill the Chef server with the Chef client cookbook so we can start to bootstrap nodes. First, we run Burks vendor to actually download the cookbook that we need. This cookbook is downloaded from the Chef supermarket. The Chef supermarket provides an API, but also a website where you can conveniently search for open source or community cookbooks that do a lot of interesting tasks for you and that you can leverage to actually achieve your goals faster. So one example, for instance, is the Chef client cookbook actually has a couple of dependencies which were also added. So for instance, the Chef client cookbook leverages cron, so it can regularly execute the Chef client. Or it leverages the Windows cookbook because Chef clients not only support Linux but also Windows. So now we have this couple of these couple of cookbooks in our local directory. So let's upload them and add them to our Chef server. By the way, if you are if you want to look up all of these things, they are also, there's a README file included in the starter kit as well that has like very detailed steps, and also how to do a quick start example. So in this example, I will just copy the command to look up or to upload the cookbooks from this README, paste it here, and now Burks Shelf is going to do the work for me and upload the cookbooks into our Chef server. This is going to take some seconds, and the other thing that I would like to show you, which is also included in the starter kit while this is downloading, is the user data. As Amir already explained, you want to connect your nodes to the Chef server so they can actually pull the recipes, pull your code, and be configured to the state that you want them to be. But you don't want any nodes to connect to your Chef server and maybe know how you do your configuration and so on. So you need to establish this trust relationship. And to do this, OpsWorks for Chef Automate has an integration with IAM and provides a registration and deregistration API. But you don't need to use this while you can use the registration deregistration API on your own while the node is booting. So in order to do this, we provided you a code snippet which you will find in user dash. And this is a shell script that you can use to bootstrap Linux instances. Most of, I think the one we would recommend is Amazon Linux to boot up. And as you can see, you can customize this, but also a lot of, like, all the real important, most of these settings are already pre-configured. So there's basically one setting for you to set, and this is the run list. So you would edit this file and use and change the run list to your needs. So it is a role that Amir referred that Amir referred to earlier. So yeah, this user data can be used in auto-scaling groups when so yeah, let's check if the cookbooks are uploaded as the command is done. Cookbooks list, and our chef server should tell us yes, he knows about the cookbooks and yeah, and in which they are basically stored in the chef. So now we know how to write cookbooks a bit from the commands or examples that Amir showed. We know how to upload them into the chef server, and we also know how to bootstrap nodes. So this is already enough to get you started and to bootstrap simple nodes and connect them. But let's take this a bit to the next level, because this is local cookbook development. I think the moment you are starting to treat your infrastructure as code, you probably also already have like a more sophisticated setup, but you also want to use your cookbooks and treat them like real source code. So you want to prevent errors from happening in production, you want to run tests, make sure there's no typos in it, and you're sure that the stuff that you roll out to production is actually ready to be there. So I built up a short example, and we will use another chef server to demonstrate this. In this example, which is this webinar demo, a chef server, we want to use a demo page. So let's say we have our nice startup, and we want to have an app server that is providing some web pages. And until now, we basically have this one EC2 instance, and it's not serving traffic because, yeah, the app is not there. Of course, this is not one single EC2 instance, but we are using a load balancer to refer to this or to tunnel traffic to. And we are using an auto-scaling group to actually start and stop instances and also attach it to the load balancer once the instances report that they're healthy. And you can see all of these, like switching over to the EC2 instances view, you can actually see all of these in my account. So you can see here, these are the EC2 instances. This is actually the chef server we are using. It's an EC2 instance in your account. And you can also see this is the web server that we are just hitting when we reload here and sadly find that our web page is not there. So let's fix this cookbook. Let's fix the chef code. So actually we have a nice app that is deployed. So heading over to our repository where we have our application cookbook, we again have the typical chef structure where we find the /cookbooks directory, and in that we have our app cookbook that we are going to edit. So let's fix this cookbook, and as this is a prepared demo, fixing is really easy. We just say, hey, enable the app. So we save this, and we do our git diff. Oh, the change looks good. We commit it and say deploy all the apps. But before we want to like send this to our to Chef workflow in order to push this change to the Chef server, we can even run local tests. So delivery, that is another command line tool that comes into play here, allows us to run local tests. So we could say, hey, local linting. Do I follow the community best practices? Is my code in a good shape? Or we could say run syntax checks, so we know at least things are not, we didn't forget like a trailing, like a comma or closing braces or whatever. Okay, so change looks good. Let's submit this to review. One thing that this is going to, workflow encourages you is to follow best practices. And one of these best practices is that you use feature branches for development. So let's create a feature branch. So delivery is happy. So we create a new feature branch and push this to review. So now we head over to the Chef Automate UI, so we can actually see it running. So here we have our Chef Automate UI, and it has like different tabs, which is like workflow, nodes, and the admin area. So let's focus on the first one, which is the workflow. We will find we have our active project here, our web app project. We drill into it. We have deploy all the apps, the code change that I just made, and we see, oh, the build failed because there is a syntax error. So we can open this up, drill down, and we will find that Chef Automate tells us we are not adhering to the best practice. It says we didn't bump the version, so Chef cookbooks are versioned by a version, so we just fixed this small error that Chef workflow prevented us from pushing to production. So let's fix this one quickly. So we added the version, bump it to, let's say, 1.0. And we again commit it, and we send it for review. And as we speak, already this already picked it up. So we, again, the unit and the linting phases are running, and also the syntax phases running. So Chef encourages you to follow the best practices, and this also includes that you do a review of the code that your coworker maybe did. So you would review the code, you can review the code, you can actually see the change. Oh, we changed this line, and you can even comment on it. So say, looks good. Go ahead, ship it. You can add this comment, so later on people can refer to it, you can see it, and we can approve the change. So now that the change is approved, it gets built into our master branch, and at the end of this build step, the cookbook, it gets uploaded to the Chef server, which will make it available to all the clients. So while we don't want this to be like, this may take a couple of seconds. Oh, now it's actually pretty fast. We can head over and see if we go to our to the right folder, we can do knife cookbook list, and we should see that the version is changing. So right now, before it was 0.5 something, 0.13, so it will basically bump to 1.0 once the build has passed. So it's still running, security, quality, and if you give it a couple of seconds more, it will basically have executed all these phases and push the cookbook to your Chef server, which is just running right now. One thing to keep in mind is that all of these phases are basically, in that sense, best practices of a process that will give you a reliable infrastructure as code handling, but you can customize it. So it means whatever it is, depending on your situation, what does this quality check mean for you? So you can customize it, and it comes with a kind of default, but you can tune it to your needs. So now the cookbook is published, and we should see that the webinar app hits version 1.0. Yay, so we have published our fixed cookbook, but how do the Chef nodes pick up this change? And this is a good question. By default, Chef clients check in every on a regular time interval, like 30 minutes would be the default. So this change is now gradually propagated throughout our infrastructure, and after 30 minutes we would see how this change happened. So we can actually see look at the nodes view and see how instances pick it up. So we can see, we head over to the nodes view and we can see, when in the last couple of seconds there was one node who just ran it, and this one will pick it up. The other one would be to bootstrap new instances, because upon boot we execute the user data, which is included in the starter kit, and this will also trigger a Chef client run. So you could also think about the scenario where you basically bootstrap new servers and then decommission the old ones. So let's try this as well. So we basically head over to the EC2 console, to the autoscaling groups, and let's say right until now we basically had our website backed by one server. So let's say now we want to have it backed by 5 servers. This will ask autoscaling to commission extra 4 web servers, and as they come up in the next couple of minutes, or a couple of seconds actually, they will also have the new page. So having seen this, let's try, if we are already lucky, to refresh our page that will basically our load balancer give us, and hey, here we go. We just deployed our first app. So yeah, I think this was it. Thanks for listening.